Look at this. I've got a couple of things I need to define first. All right, so my independent variable. All right, these are the inputs. All right, so what I'm putting into a function, usually x. Right, it's usually my x variable. Okay, so the variable you put in, it's the one that you control. Right, so you're controlling what the independent variable does. The dependent variable, right, is your outputs. Usually we're going to refer to these as y, right? So generally speaking, x and y, x will be your inputs, y will be your outputs. So this is what changes based on the independent variable. Okay? So we're going to look at kind of this relationship here between the number of rectangles, right? So the number of rectangles and the perimeter of those rectangles. Okay? So can anybody remind me what perimeter is again? What do you mean by the outside, Gavin?
Like all the space around it?
All the distance around the outside. Yeah, awesome. So if I look, right, so if I have one triangle, right, so that's this one right here. What's the perimeter of that rectangle?
14. Yeah, it's 14.
So, a couple people saying 14. Problem is I only see 7. So I have to count the other sides, right?
Can we add them?
So I'm going to add those together. Right? I need to add all the sides together so I know rectangle opposite sides are the same. I want to make sure I add everything together. Okay? So I'm going to move on. I'm going to fill in the rest of this table. So if I look at that and I think that same kind of thing, right? To make sure I have these sides. What's my perimeter of 2 rectangles?
20.
No. 16. Right? 6 plus 6 is 12. Plus 2. Plus 2 is 16. Okay, what about 3 triangles? 18. You notice the pattern here?
Yes. Goes up by 2.
Goes up by 2. So 4 is going to be 20. You could check that, right? I could say 6 and 6 is 12. You have 13, 14, 15, 16, 17, 18, 19, 20. Good. So now I've got a table that represents this relationship. But now I want to write an equation. So we just said, right, these all go up by 2. What is that? If we think back to linear equations, right, when we talked about graphing all these different types of equations and writing them, thinking some terms we use there, what is this plus 2? It's the slope, right? It's what changes every time. So this, right, is my slope. So now if I'm starting to write this as an equation, right, I have y equals, right, and then, so we said my slope was 2. So I'm going to take, and so just like when I graphed linear equations, right, that slope goes with the x, goes with the independent variable, because that's what's affecting the change, okay? So, but now, what was the other part of a linear function that was kind of in that form? The y-intercept. So now you think about, how do I figure out what that y-intercept is? So here's where I go and I look. What happens if I plug in 1, right? So I know for one triangle I need a perimeter of 14, right? So if I plug in 1 for x, right? So it'd be 2, right? What do I need to add then, Deegan, to get to 14? 12, right? So if I think of 2x plus 12, now I just want to check. right? Does that work for the rest of my things, right? So what's 2 times 2? 4. 4 plus 12 is 16, right? So good, I've got a good equation. There's my equation, right? So we're going to work through one more example of this, but you got to make sure we're asking ourselves those questions, right? Thinking about what's the slope, what's the kind of y-intercept. We're going to do that. So before we look at that other relationship, a couple more vocab things. All right, so a function, we've looked a lot at functions, right? We've graphed them, done all that stuff. But we've never really defined what a function is until now. So a function is a relationship that compares the inputs, right, your x's, with exactly one output. So exactly one output. So for every input, there's just one output. Right? So everything we graphed in chapter 5, right, was a function. Constant slope, constant rate, yeah, all good stuff, right? That line was straight though, right? So all those things you just said were true, right? Constant rate of slope, steep, sometimes. All that stuff was true, right? Straight line though. We didn't look at anything where the line's kind of curved, right? That'll come 2 chapters. Okay? All right, so let's flip the page. We're going to look at one more relationship and then talk about a couple different ways we can represent these things. So if I look at that table right there, John, can you tell me what independent variable is?
The left.
The left, which is what?
The number of photos.
Number of photos, right? So that's my x. Those are my independent variables, right? Tyler, can you tell me what my dependent variable is? Memory, right? It's the other one. So now let's look at this and say what is happening here, right? So when I have 0 photos, right, I have 512 memory. 1 photo, I have 509. So first thing I want you to do when you look at these kind of things is say, look to see if there's a constant rate of change, right? So how would I go from 512 to 509? Subtract 3, right? Does 509 to 506 have that same property, right? Subtract 3? Yes, no? Yeah. And 506 to 503. So I'm subtracting 3. So we get. So now let's talk about how we can represent this using words, an equation, and a graph, right? So I want you to take a second, right? Just think to yourselves, how could you represent that using words, right? If I said, describe to me what's happening, how would you guys? So, anybody got one that they want to share? Tabitha?
Every single photo
Yeah, right? So I could say every photo I take. I lose 3 memory. Awesome. So sometimes it's nice just to be able to describe what's happening, right, in a situation. So now we're going to look at the equation again, right? So what's going to be really key in my equation? What did I figure out from the table? Kaden, what does that -3 represent? The slope, right? And so if I look at the slope, right, slope goes with what variable, Michael? What does the slope go with? What variable? What variable does it go with? Don't just repeat what people are telling you. Think about it. X, right? Slope is always with the x. So I have -3x, right? So there's my slope, that's what I found out. But now I've got to figure out what do I need to, I'm going to have to add something, right? So here, I have an x value of 0, right? Use that to help you find your y-intercept if it's there, because it makes your life so much easier, right? Because what is 3 times 0? 0, right? Anything times 0 is 0. So what would I have to add to 0 to get to 512?
1.
512, right? 0 plus whatever. So plus, help if I wrote that. 512. Okay.